Assalamualaikum and hello everyone. Today I will do a presentation about our mini project on computer aided science DJJ30122. We are from Polytechnic Kota Kinabalu. My name is Qasthinah Binti Esia, and I will introduce about our member, Datu, Mohamed, Khusyairie bin Tajuddin, Steve, Siaw, Kwok, Cheng, and Mohamed, Danish, Zakwan bin Sanawing. Let me explain about the introduction first. Computer-aided design, or CAD, also known as computer-aided design and drafting, CADD, is the use of computer technology for the process of design and design documentation. Computer-aided drafting describes the process of drafting with the computer. CAD software or environments provide the user with input tools for the purpose of streamlining design process, drafting documentation, and manufacturing process. CAD output is often in the form of electronics, files for print or machining operation. Next, Autodesk Inventor. Autodesk Inventor is an engineering design software developed by Autodesk. Inventor is similar to AutoCAD, another Autodesk software in that both create precise 2D and 3D models. However, this software has different terminology and workflows that makes the transition tricky when first navigating Inventors if you are used to using AutoCAD or SolidWorks. Unlike other 3D systems you may have used in the past, Autodesk Inventor is a parametric, feature-based system that allows you to create 3D parts, assemblies, and 2D drawings. Parametric modeling is a bit different from modeling in AutoCAD, which is object-driven. In a parametric modeler, everything is controlled by either parameters, dimensions, or relationships. For example, if you want to move the position of a hole in a block, you will change the dimension or relation that controls its position in a parametric system. Okay, first, I will explain about drawing part description. Part 1 is front cover. Front cover is to provide an interface with the washing machine. From the top view, the length is 15 mm and the width is 1.5. From the front view, the height is 20 mm and the length is 15 mm. So as you can see, the diameter is 14 and the inner diameter is 12. Okay, next. The next part is detergent drawer. Detergent drawer is to put the detergent into the washing machine. From the top view, the height is 7 mm and the length is 3.5. The radius of the fillet is 1.1. From the front view, the height is 2.5 and the radius of the fillet is 15.18 and the length is 3.50.
Hello, my name is Mohamed Zakwan and I will be presenting from part 3 to part 9. Part 3 is the body machine. This is the main body of our washing machine project. It has the dimension of a rectangle 15 x 15 x 20 mm. Part 4 is the worktop. The function of this part is for the top cover of washing machine. It has the dimension of 17 x 16 x 1 mm. Part 5 is the side cover. The function is for both left and right cover of washing machine. It has the dimension of 17 x 20 x 0.5 mm and has the air ventilation system. Part 6 is for back cover of washing machine. It has the dimension of 15 x 18 x 0.5 mm, air ventilation system and a hole for the hose. Part 7 is the door glass. This part will be combined with part 8. It allows user to see the clothes being washed inside the washing machine and has the diameter of 12 mm. Part 8 is for the door. It is to keep the clothes inside the washing machine while being washed. It has the diameter of 12 mm for the door glass and the radius 6.5 mm for the door. Part 9 is the wire. It allows electricity flow to the washing machine. The washing machine won't work without electricity. That's all from me. Let's move on to the next presenter.
Next is the control panel. The length of 10 mm and width of 0.5 mm and each button is 1 mm length. This is the electronic device that controls the washing machine. part 11 is the screen that has 3.8 mm of length and 1.4 of height and 0.2 width. This is placed on the control panel. The next part is the tube, which is inside the washing machine and used to wash clothing. The dimension is 1 radius of each half circle around the tube. The dimension of the tube circle is radius 5.5 mm outside and 4.5 mm inside. We got 3 pedals on the tube that has 1.2 mm length. The overall length of the tube is 13 mm and width of 11.53 mm, including the tube half circle around the tube. The part 13 is the drain hose, which removes water from the tube during the spin circle. The curve of the hose is 11.5 radius and the straight hose is 24 millimeters and the width of hose is 2 millimeters. Next is the debris filter, which is to arrest all debris that may obstruct and interfere with the cooling water flow. We got 2 mm length and diameter of 1 and diameter of 1.5 for the upper part of the filter. Now is the emergency drain, which used as another drain hose in special situation. The hose length is 1.5 mm and the opener is 0.5 mm and 0.5 diameter. The last one is the filter cover that used to filter the dust and dirt. It has a length of 3 mm and height of 1.8 mm.
Okay, now I'm going to present the assembly drawing and exploded view. This is assembly drawing for our mini project, which is a washing machine. After we finish drawing the washing machine, we make a new sketch and create standard IDW drawing file. After that, click best to choose the file we would head assembly and place the washing machine with view that you want, such as front view, top view, and lastly a side view. Make sure to choose the millimeter for our drawing. After that, we set up the scale as 3:1 ratio. Then we create the 2 sections, which is section A and section B, so that we were able to put a dimension of the drawing and make other people to understand our drawing dimension easily. Moreover, we can create another side part of the drawing that we want to display as shot next to the section A view. To make a dimension, we can just click the baseline and click the every vertical side so that the dimension will come up simultaneously. We can do the same thing for the horizontal side. Furthermore, we can also use dimension and just click the line or one point to another point with its dimension. Okay, now for the exploded view, we also create a standard IDW drawing file and then choose a balloon button and select every part. Then the balloon will automatically come out, and after that we create the part lists as shown at the slide. It will show the item, the quantities, and also the part number. So this is the video presentation of the exploded view, and it will come out as shown as the presentation slide.
Okay, lastly, the conclusion is eventually there are many things that we can learn from the process of creating this washing machine model. We also learn how to use these covers in a variety of ways, including making sketches in 2D and 3D objects, extruding, and assembling projects. At the end of this project, we also learn how to assemble by part and create a bomb. We will be able to create a washing machine model using all of these things. We hope that the knowledge that we gain through this learning process will help us find jobs that are related to Inventor, and that we will be able to create more projects that use Inventor in the future. That's all from us. Thank you.